Chinese is a very interesting language. Let's see a sentence. 明明白白喜欢他. It's very strange, right? So normally in English, 明 means bright or light, 白 means white, 喜欢 means like, and 他 means he or him. So if we just put those words all together, it doesn't make sense. It's very strange and hard to learn. But it does make sense if we think it in another way. Ming Ming plainly knows Bai Bai likes him for nothing. It's very easy, right? So, in Chinese, Ming Ming could be a Chinese name. And if we put Ming with another word together, it could be something else, for example, Ming Bai. Anyway, Chinese is very hard to learn, and I believe it's hardly possible to understand that sentence without tens of years of learning. I'm going to introduce a friend who knows Chinese very well without tens of years learning Chinese. And I'm so glad to invite Dr. Xie Lingxi to tell us more about this friend, Huawei Cloud Pangu Model. Let's go and find him. Hi, Doctor.
Hi, nice to meet you.
Nice to meet you. Let's get started.
Yes.
I just started with a simple example to explain what Pangu can do for us. So can you give us more details about it?
Okay, so the Pangu large model is a large-scale pre-trained deep neural network. It can involve something like convolutional neural network or vision transformers, and by combining these models into a big pipeline or a big architecture, Pangu can incorporate something like contrastive learning, mask image or language modeling to get pre-trained, and after that it can apply to a lot of downstream applications such as computer vision, natural language processing, multimodality processing, and so on.
It is too hard for me.
Okay.
So how about this? Can you start with a basic introduction about why Pangu was created and its design philosophy?
Okay, so for many people, maybe we can start with the AI technique. The AI technique, it was designed for doing something that is too complicated or something that's too redundant for most people. So the key to AI technique is it must be general to a lot of problems, which means that you have one algorithm, you have one model, and you can apply it to many different problems. That is the core goal or core target of AI. Before deep learning emerges, AI consisted of a lot of manually designed techniques, such as the local features for images, the local descriptors for natural languages, but these techniques are not general. Around 2012 or 2011, the deep learning techniques emerges first in the natural language processing and then on computer vision. The main benefit of deep learning was to provide a platform that allow you to do something, a lot of different applications using one general pipeline. So that is deep learning. But deep learning has also brought a new issue for us. For example, deep learning is incorporated with large-scale deep neural networks. The deep neural networks has a large number of parameters. Even the smallest deep neural network often has more than 1 million parameters. And nowadays, the large models can have more than 1 billion or 100 billion parameters. So how to tune these parameters to the best status is a very important problem. You know, the good parameters and the bad parameters can impact the performance a lot. So the core issue in deep learning is called optimization. That means you are given some data. Sometimes the data is limited. So you need to tune the model on the data set so that the model can achieve a good status. Different data can have different properties. So people are designing a lot of techniques or a lot of tricks to tune the parameters. But this is difficult for us to perform this process on a large number of different applications. So you can imagine that we are Huawei Cloud, right? So Huawei Cloud can get a lot of projects from the requirements are very different. You need to tune a large model to fit different projects. That is a difficult issue. For a lot of our engineers, if you work on tuning parameters for one project, you can get like 3 to 5 engineers to tune that for 2 or 3 months. That's only for one project. And we have hundreds or even thousands of projects every year. So that is a big cost. What makes things worse is that, some engineers can leave the company. If they leave the company, the experience that they have on this project can live with him or her. The engineer that takes his or her work cannot inherit the experience. It is very difficult for him or her to learn from the experience and to continue with the project. All of these are giving us a big issue that names AI customization, which means that you have an AI algorithm. AI, as I said before, the goal of AI is to make everything general, but you need to customize the AI algorithm for each project. But the difference between these projects makes it difficult for us to apply one algorithm. But to use different algorithms, you have a large cost. So what to do that? We have the Pangu large model. So what is a large model? It is a large-scale pre-trained model. What do we mean by pre-trained model? We mean that to incorporate a large number of data. The data can be very, very big. For example, for images, we have more than 1 billion images crowd from the internet. And for natural language processing, we have more than 40 terabytes of texts crowd from the internet. So when you feed so much data into the deep neural network model, it can learn some knowledge from this data, and it can store the knowledge, the general knowledge, in the large-scale parameters of itself. So when you have a new project, for example, you need to recognize an animal in the wild, so you can borrow the pre-trained computer vision model and you can tune the parameters on the relatively small data set of the animal. So why does it work? Because when you have trained on a large corpus of image data, say more than 1 billion image data, then even if the downstream task, for example, the animal recognition, you have only about several hundred images. You can easily tune the parameters because most of the parameters have been well tuned using the large upstream data. So in the downstream, you don't have many things to do. You can just tune it easily, and both the tuning time and the effort you use to tune the hyperparameters will be lowered significantly. So that is why our Pangu large model can be used to a lot of downstream tasks. According to our experience, you can reduce the costs, for example, the development cost by more than 80% or 90% using this paradigm, because you have a large pre-trained model. So that is our goal. But although the scope is good, but there are many techniques that we need to do to implement this framework. That is why our team has spent a lot of efforts in developing new algorithms, techniques, or some engineering tricks to implement this.
So therefore, I understand that the Pangu model can learn from some small data samples and help us to solve the problems of AI model customization and application development fragmentations. Okay, it's a very long sentence. Anyway, and I know Pangu has a big family. What are they?
Humans understand the world using different data modalities such as images and text and sounds and so on. So Pangu also has a large family to deal with different data. For example, to deal with individual data, Pangu has a CV or computer vision model that is designed for understand image data. For example, it can use for image recognition, image captioning, image generation or something else. And the second one is the Pangu NLP, or Natural Language Processing Model, that was designed for text or sound understanding. For example, you can use it to understand the semantics or meanings in an article, or use it to write an article, or use it to deal with a dialogue with humans. And the third one, naturally, we have a Pangu model that was designed for multimodality data. That is Pangu MM model. It can deal with the communications between the images and text and sound and so on. And beyond these things, we have also Pangu graph model that was used to deal with structured data. Graph is an advanced concept in computer science that was some nodes are connected with some edges, so that you can represent the relationship of different data elements using the graph structure. So it can be used to deal with structured data such as tables or some economic records or something like that. And the final one is the Pangu scientific computing model. So what do we mean by scientific computing? It means that you can use the AI techniques to deal with something such as simulation, computation in the scientific domain. For example, you can use it for forecasting the weathers or the sea level wave heights or something like that. Or you can use it to predict the protein structures, such as the Google's AlphaFold. These things belong to the scope of scientific computing. So we have also Pangu scientific computing models for these purposes. So that is a large family. And we are also expanding this family today. For example, we are designing some new models for recommendation and search. We hope they can improve your experience when you are using some search engines, or you are using some recommendation engines. So we are hoping to do that. So we are still adding something into the Pangu family.
I think it sounds very interesting.
Yeah.
Can you tell us how to use Pangu model in the real life situation, like put it into more industries?
Okay, so Pangu has been applied to a lot of real world scenarios. For example, you are using Pangu to a production line that's producing electronic boards. You need to apply the AI algorithm, or in particular the CV algorithm, to detect anomalies on the electronic board. For example, there is a scratch on the board. You must tell the manager that you find it. But this is a difficult task because the pre-trained data does not include such images. For example, you need to use some automatic machine learning or auto ML techniques to extract the proper sized model to fit the computational budget. You need to perform some data efficient fine-tuning algorithms to tune your model from the natural image domain to the specific image domain that contains electronic boards. So all of these are combined into our Pangu pipeline so that everyone can use it easily. For example, we have offered the pipeline as an online service, so that you visit our website, you have an account, so that you can directly use our pre-trained model to do the things. AutoML algorithms, the fine-tuning algorithms are automatically called to fulfill your requirement. Also, the price is a lot cheaper than you develop your own pre-trained model, because not every company or every person can develop his or her own large model. You need a lot of engineering to build up your own pre-trained data set, to train the model on a lot of GPUs. That is very expensive. But when you are using the Pangu model online, it's much cheaper.
Yeah, it seems like it's like a one-stop, full stack AI application platform, something like that, right?
Yes, yeah. That's our hope, because the Huawei Cloud is to use the large model as a part of the full stack service to make AI affordable for more people. As I said before, Pangu has been applied to a lot of scenarios, different scenarios. I have an example in the CV domain, but there are also something like NLP domain, the multimodality domain, something like that. But I will not go through this today because my colleagues will introduce them later.
So having learned so much, and
I think my brain capacity is a little bit insufficient. Could you sum up today's content in a few sentences?
In the deep learning era, the large-scale pre-trained model with its downstream pipelines is a summary of all advanced techniques, algorithms, and engineering tricks, and so on. So we believe that the large-scale pre-trained model will be the trending techniques in the future 3 to 5 years, and it is indeed our most powerful weapon that we have now. So it will be the most useful technique when we are developing AI applications. And we hope that the Pangu model and our Huawei Cloud will serve as a basic tool for many AI applications to serve the people.
Excellent. Doctor, thanks for your interpretation today.
Okay, thank you.
Thank you.
Thanks for watching this episode on Cloud Focus. I hope you like it. Please scan the left QR code for more documents about Huawei Cloud technologies and the right QR code for more help in a Huawei Cloud Developer Forum. There's more to come, so stay tuned. I'll see you next Wednesday.